Yeah. So up till now we have been discussing about the calculation, how to calculate and all, right? Single stage extraction, multi-stage extraction. We have been discussed. Now let us discuss the problems. First one, a solid material is used as an adsorbent to separate a color component or a color component from an aqueous solution. That is nothing but a solid substance is used, or a solid adsorbent is used for separation of a color component from an aqueous solution. So there is an aqueous solution in which you have added some coloring agent or food color. In basically daily life example, if you take, you are adding food color in that and it has become colored solution. Now we have to separate that we have to reduce the part of color from that. Okay, so you are using in solid adsorbent there. Okay, initial concentration or initial value of the color is around 48 units. He is telling that it should be reduced to a final value of 10% of the initial value. That is 0.1 into 48. Why 0.1? 10%. So 10 by 100. So 1 by 10. So 0.1. 4.8. And he has given the equilibrium data as kg of adsorbent that is used per kg of solution. Okay. And Y value, that is your equilibrium color values, are also given. 0, 48, 43, 8, 43, 31.5, 21.5, 8.5 and 3.5. 0, 0.001, 0.004, 0.008, 0.02 and 0.04. These are the values. Now you have to calculate. He has not given the x value. From the data you can see he has not given x value. Why? Because x value is what? What is x? Kg of adsorbate, or you can say in simple kg of solute per kg of adsorbent. And what is equilibrium color, which is y value? That is nothing but kg of solute per kg of solution. Right? Kg of solution. Kg of solute per kg of solution is y. But we want x is kg of solute per kg of adsorption, which is not given. So we will calculate how kg of solute by kg of solution by kg of adsorption by kg of solvent. So y by this value, y, that is equilibrium color value, by this value will you get x value? Yes. So kg of solute per kg of solution is y, right? Dividing that by kg of adsorbent per kg of solution. Right? So kg of solution get cancelled. So kg of solute plus by kg of adsorbent. That is the requirement. X value. Clear? So this is how you have to calculate x. Now I will show you how do we calculate the x value. So x value, initially when there is no adsorbent used, there will be no solute in the absorbent. So no need to calculate. In second case, initially the color is 48, it is reducing to 43. Right? 48 to 43. How much adsorbent it is used? 0.001 to 0. Initially it is 0 to 0.001. Same way, next for 31.5 it is 48 minus 31.5. Converting from 48 to 31.5, how much of adsorbent is used? 0 to 0.004. Right? Next, 48 to 21.5 it is reducing. How much of adsorbent is used? 0 to 0.008. 0 to, 48 to 8.5 it is reducing. From there 0 to 0.02 is the amount of adsorbent that is required. The same way for 48 to 3.5. How much of adsorbent is required? 0 to 0. So this is how you get your X values. Clear? Please do the calculations. I'll explain you the procedure, do the calculations. Yeah. Now you got your X and Y data. X and Y data is obtained. So what, as usual, plot the curve. For this X and Y data we have plotted the curve. Clear? After this plotting, first he has given find the adsorbent required. Question A, find the adsorbent required when adsorbent required is nothing but SS when 1000 kg of solution is given. That means LS is 1000 kgs. And to refer the question, please refer the notes that I am sending it to you. Okay. So initially at single stage, what is the SS required? So minus SS by LS is equal to Y1 minus Y0 by X1 minus X0. We already know this for single stage. Now LS is 1000. So what are the points? X0, Y1, X0, Y0 and X1, Y1 are the points, right? X0, Y0. X0 is 0, absolutely, because initially there is no solute that is being settled on the adsorbent. So on the solid, initially when you are giving the solid material or the adsorbent, when you are getting in that, that is getting in contact with the aqueous solution, there is nothing settled on the solid. So it is 0. So Y1 is what? Final value after the stage that you get out, which is 4.8. Minus Y0 is the initial value, which is 48. But X1 value you don't have. So what you do? X1 value, if you want to find, you have to use what is the point? X1, Y1. So what is Y1? Y1 is nothing but your final Y value, which is 4.8. So at 4.8 in the graph in Y-axis, from here draw a straight line which passes through the X-axis, parallel to the X-axis. It cuts the equilibrium curve at certain point. So from that point, drop a line down which cuts the X-axis at certain point. That point is your X1 value. So from this graph, you will get your X1 value. Some value you say around, some value you will get. I think you get 1700 or something. Some value you will get. Some X1 value you are going to get it from the graph. So all the values are known. So you can calculate minus SS. 4.8 minus 48 by 1000, by X1 into 1000. X1 you are getting from this graph, right? So you can get SS. So for single stage, this is the amount of adsorbent required. Clear? Now, he is asking, what if two stages are used? What if two stages are used? What is the amount of adsorbent required in individual stage? In individual stage, what is the adsorbent required? An intermediate color concentration he has given as 24. So for stage 1, SS1 will take SS1 by LS, SS1, this you take it as SS2, Y0, here you get Y1, Y2. X0, X1, X1 only. Why you are taking it as X1? Because in each stage you are adding. It is not co-current or parallel. So you are adding. It is cross current product. So every stage you will add X0. So every stage you will get out X1. Okay. So SS1 for stage 1 first we will take. SS1 by LS1 is equal to minus SS1 by LS1 is equal to Y1 minus Y0 by X1 minus X1. As usual, X0 as when you are entering the adsorbent, as you are when the adsorbent, that is your solid, when it is getting in contact with the solute, initially there is no solute that is being settled on the solid surface. Hence this X0 value will be 0. LS is already given as 1000. Y1 is 24 here. You can see in second two stage, no? So intermediate is given as 24 in the question. Minus initial concentration 48. By x1 you don't know again. How will you calculate x1? The same procedure. What are the points? x0, y0, x1, y1. So x1, y1 is what here? 24. So at 24 from y, from the graph again, you take the graph of equilibrium curve that you have drawn. So at point 24, somewhere you will have here 24 value on y-axis. Draw a straight line parallel to x-axis as usual. It will cut the equilibrium curve at certain point. Drop the value. Drop a straight line which cuts the x-axis. The point where it cuts on x-axis will be your x1 in this case. That will be your x1 in this case. Okay. So you got your x1 value again. So minus SS1 is equal to 24 minus 48 by x1 into 1000. X1 value already you get from the graph. Clear? This is for stage 1. In this stage 2, now we will discuss for stage 2 how to do. Same thing. Minus SS by S2 by LS is equal to, in this case, it will be y1 minus, it will be y0 minus y2. It should be always from the initial condition only you need to take. Okay, this derivation will be always from the initial conditions. It will never be from here. Remember that. Whenever you are writing SS2 also, it will be y2 minus y0 by x1 minus x0 only. It will be y2 minus y0. It will not be y2 minus y1. It will always be from final to initial or intermediate to initial or any stage. You will always compare with the initial value only. So it will be y2 minus y0. Don't take y2 minus y1. Don't get confused here. Always final minus initial only. That's what I took this as y final to avoid confusion. In the question, he has given directly that 10% it should reduce. Even whether you do 2 stage or 3 stage or 1 stage. Doesn't matter. So now in this case, y2 will be, how much it should reduce final value to 4.8. So here y2 will be 4.8 minus y0 is 48. This is 1000. X1 value you don't know. So x1, y1, x0, y0 as that are the points. At x1 you have to find out at what point? 4.8. You already calculated that. At 4.8 what is the x1 value? You are already getting it from here. You already done it. So at 4.8 it draw parallel line to x-axis. It cuts an equilibrium curve at certain point. Drop the line on x-axis. It cuts the x-axis at certain point. That is your x1 value. So again you get x1 value. So your SS2 value will be 4.8 minus 48 into 1000 by x1 minus SS2 value you will get. So SS2 will be, anyway this is positive. You can find out SS2 from this, right? So this is for how do you do the problem. So this is the first problem. Once again I am repeating, he has given the initial color present in the solvent is 48 and he is telling that it should reduce to 10% of the initial value, that is 4.8. First thing, he has given the data of kg of adsorbent per kg of solvent and equilibrium color. So he has not given us the x value because x value is kg of adsorbent per kg of adsorbent. And what is y value? Equilibrium color, which is nothing but kg of adsorbate per kg of solution. So from y by that is your equilibrium color divided by the given value, that is your kg of adsorbent by kg of solution. If you do, you will get your x value. Please refer the previous time. Just move backward in your video and just check how clearly I have done that. So you will calculate x value. Once you calculate x and y, plot the graph. So for single stage, initial y0, final is y1. So it will be 4.8 final value. So SS by minus SS by LS will be y1 minus y0 by x1 minus x0. So you have to calculate x1 value because y1, y0, LS, you know x0 is equal to 0 because initially whenever you are giving the adsorbent or the solid material in contact with the solute, initially there are no solute particles that are settled on the solid material, right? So x0 will be 0. So x1 you have to calculate. y1, y2 you know. So at 4.8 that is your final value, that is your y1 value. What is the x1? This is your x1 you will calculate. So SS by LS, LS is 1000. So mine is equal to y1 is 4.8 minus 48 by your x1 value from the graph. So that will give you SS value. Now in second case he is asking, when you are using two-stage operation, what is the individual adsorbent required in each case, and the intermediate value is of the color is 24. He has given this data. So same thing for first stage you will do, for the second stage you will do as you have done in your single stage. And always when you are going for stages, multi-stages also, please remember your final value will be always compared with the initial only. So for first stage it will be y1 minus y0, for second stage it will be y2 minus y0, third stage it will be y3 minus y0. Don't go for consecutive values like y3 minus y2, y2 minus y1, that is wrong. It will always be from final to initial. So y1 minus y0, y2 minus y0, y3 minus y0, y4 minus y4, it depends on how many number of stages you have. Please be very careful when you do this problem. So now moving to the next problem. One more problem is there. An aqueous solution containing valuable solute is colored by some small impurities. It is decolorized. So you are again decolorizing using a carbon adsorption. Means here your solid is carbon or adsorbent is carbon. Okay. And original solution has initial color of 9.6. Initial Y0 value is 9.6. It is determined to reduce the color to 10% of its initial value. So final value will be 10% of the initial value. Same thing, 0.1 into 9.6, which is 0.96. Okay. The equilibrium data is given below. The equilibrium data, that is kg of carbon. Again he has given kg of adsorbent by kg of solution only. He has not given x value. And equilibrium color value. So 0, 9.6, 0.001, 8.6, 0.004, 6.3, 0.008, 4.3, 0.02, 1.7, 0.04, 0.7. Okay. Now we have to again calculate x value. What is x? He has not given. X value is what? Kg of solute per kg of solvent, adsorbent, which is nothing but carbon here. So again the same thing. Please move backward in the video and just check it out for the how to calculate the x value in this case. Please do that. Okay. Now he is asking the first question. The first question is, convert the data to form a suitable plotting for adsorption isotherm, and does it follow the Freundlich equation or not? If yes, find out the constants. So first we have to form the data. You found x and y values, right? Y is given, you will find out x values. Now for Freundlich equation, what is that Freundlich equation? Y star is equal to m into x power n. Apply ln on both sides. So ln y is equal to ln m plus n into ln x. So you have to plot a graph for ln y versus ln x. Listen, plot a graph for ln y versus ln x. So what you will do, x and y values once you have got, ln y and ln x values you calculate. You will get x and y, isn't it? Calculate ln x and ln y. After calculating ln x and ln y, plot a graph for ln x versus ln y values. If you are getting a straight line in this way or in this way or in this way, in some form, it should be a straight line, all the points like this or like this or like this, some way. It should be a straight line, all the points when you join, it should be a straight line. If you are getting a straight line, then it follows the Freundlich equation. If it is a straight line, then it follows Freundlich equation. So what is the first question? Convert the data for suitable plotting of adsorption isotherm, and does it follow the Freundlich equation or not? So first you have converted the data, x and y you found, ln x and ln y you found. So you have plotted it, and if you are getting a straight line, it follows Freundlich equation. Now here say, if it is following Freundlich equation, then you have to find the equilibrium constants. So what will you do? It is following now. Let us assume that and definitely in this case you will get a Freundlich equation. It is following. You will get a straight line. It follows the Freundlich equation. This given data will follow the Freundlich equation in this problem. So take any 2 points. You will have, I think, 4 to 6 points. I think some points. Number of points. How many you have? 1, 2, 3, 4, 5, 6 points you have. 6 points you have. So you have found, now you have still, okay, this you did. ln y, ln x you found, right? You got a straight line. Now it is following a Freundlich equation, we came to know. Now from this data of ln x and ln y, select any 2 points. Any 2 points. 2 points and find the slope. That is ln y at any point. Second point minus ln y of first point by ln x at second point minus ln x at first point. Means whatever this value you have, this second value minus first value by second value minus first value. Don't do again ln. It's already ln. Again don't do ln. You are taking 2 points, difference of y by difference of x, that is slope, y2 minus y1 by x2 minus x1. Don't calculate again ln, it is already present in ln. Your graph of y versus x is in the form of ln y versus ln x. So whatever is your difference of second minus first, directly you have to do again. Don't calculate ln, please. So this is how you get your slope in this case. So you got your n value. Now to calculate m value, you will use this condition again. Y star is equal to m into x power n. Y star is equal to m into x power m. M into x power n. So y star. You take any 1 point from this now. You took 2 points, right? 2 point slope. Now any 1 point you take. Okay, from these two only you select any point or any point from the given data. You consider any 1 point. Let us say I will select this first point. So that first point, here it is y. Here it is not ln values. These are not ln values. These are your y values. So at that corresponding point, whatever is the y value, at this corresponding point, whatever is the y value, you place it here. Is equal to m into, at that point whatever is the corresponding x value, that you place into x. Power n already you got from the slope. Now all the values are known, so you can find m y by x power n. So first thing you have to, for verifying whether it is Freundlich equation or not, what you have to do is, first x value you have to find out, because he has not given the x value directly. So after finding x value, you know x and y values now. Now you will have to plot for ln y and versus ln x to check whether it is following the Freundlich equation or not. So you will plot for ln y versus ln x and you are getting a straight line. If you get a straight line, it follows the Freundlich equation. So when it follows the Freundlich equation, you have to find the constants now, m value and n value. So to easy for our making calculations easy, you have plot ln y is equal to ln m plus. So what is Freundlich equation? Y star is equal to m into x power n. Apply log. Ln y is equal to ln m plus n into ln x. This is normal, you all know everybody. So y is equal to mx plus c form. Y is equal to mx plus c. M is here n. So slope you have to find out, which is nothing but n. So what you will do, from the given data, you select any 2 points. So this value, any 2 points you select, second value minus first value by second value minus first value. You will get your slope. You will get the slope value. After you get this slope, now you have to find, you got your n value, that means. Now you have to calculate m value. So what will you do? You will consider this equation again. Y star is equal to mx power n. Now you have to consider any point from this given data. Any point from the given data. Okay. So at that point, whatever is the y and x value, not ln y, ln x. This is y and x. This is not ln values. These are not ln. Don't get confused. These are not ln values. Don't get confused here. So any one point you select. From that x and y values you found from the given data, select any one point. So you will have that x and y values from the data. X value, y value will get from the data. N value you already have from your slope. From the slope you will already have your n value. So you can calculate m is equal to y by x power n. Y and x you have selected one point, right? For that point y and x you substitute, n value you will get. N value is already calculated from the slope, you can calculate your m value. So is it clear? This is how you verify the friendly equation. This is your first part of the question. Now, second part. Determine the quantity of fresh carbon. That is nothing but carbon is your adsorbent here. Fresh adsorbent required for 1000 kg of solution. So Ls is equal to 1000 kgs of solution for single stage adsorption. For single stage, I already said you in the previous problem how to solve it, which is Ss by Ls is equal to y1 minus y0 by x1 minus x0. Initially, x0 value will be 0 because there is no solute particles in the settled in the adsorbent initially. So this will be 0. Y1 value is, this is minus Ss, okay? Yeah, y1 value is, it is converting final value, only single stage. So final value will be your y1, which is 0.96. Minus y0 is 9.6. Now you don't know x1 value. Minus Ss by Ls is what? 1000 kgs. To calculate x1, you have to plot the x versus y data. X versus y data. At so what are the points? x0, y0, x1, y1, right? So at y1, what is y1? Final value, which is 0.96. At 0.96, draw a straight line parallel to x-axis. It will cut the equilibrium curve at certain point, and then drop a line towards x-axis. So it will cut the x-axis at certain point. That will be your x1. So you will get x1 value from the graph. So now you got x1 value. So you can simplify and get Ss value from this. That's your single stage operation. If you still have doubt, please move backward in the video and just check it how to calculate that. Okay? It's simple. In the previous problem, I already said you this, single stage. Now, the twisting in this question is the third bit. Calculate the fresh carbon feed required for 3-stage counter current process. For 3-stage counter current process. In previously, we have solved 2-stage for cross current. 2-stage for cross current. Now it is counter current. In such cases, what you have to do is, you don't have any other option and he has not given you the intermediate values also. So in such cases, what can you do? What can you do? So 3-stage counter current process means Ss by Ls is equal to minus Ss by Ls value will be what? Y3 minus Y0 by X1, X3 minus X0. It is counter current, not cross. So you will have X3, not X0. In previous, you had counter current, right? Sorry, in previous you had cross current. So you had the intermediate value he gave you, so easily you calculated. Now in this case, he is telling that it is not cross, it is counter. So feed is entering this way and another you have in this direction. This is what is counter current. In this case, he has not given you intermediate values also, and that you have 3 stages and no intermediate values. And for cross counter current, in cross current what happens? Ss, every stage you will have x1, x0, x1, x0, but in this case, you will not have like that. For third stage, third value, x3. For fourth stage, you will have x4. In the same way, you will get right? The same way you get. Or else if you still have confusion, let it be x1 only. No issues. Don't get anywhere confused. Leave it. SS by LS is third stage. So y3 minus y0 by x1 minus x0 as usual. Okay. Third stage, SS by LS will be y3 minus y0 by x1 minus x0. Na? Okay. For single stage, what is it? Minus SS by LS is y1 minus y0 by x1 minus x1. For third stage, only change this y1 to y3. That's all. That is your final value. And in this case, your y3 value will be 0.96 directly. Final stage only, no? Final is always final value. Already I said you in the counter current process in the first problem. You can check it that. So minus SS by LS is 1000. Y3 is 0.96 minus Y0 is 9.6 by X1. X1, right? Now the twist here is, in this case, the twist of thing is, you have 3 stages in this case. 3-stage operation. So, at this point, y value, y1 value required. Y1 value, what are the points? y3 comma x1, x0 comma y0. Okay. So x1 point you have to calculate. You know y3, right? So from y3, draw a parallel line which passes through the parallel to the x-axis. But now he has given here in the question that it is 3-stage. And in intermediates, you don't have intermediate values. There you had intermediate values. So what did you do? You calculated, it passes through parallel to x-axis, it cuts the equilibrium curve, you plotted, you got the x1 value. Here it cannot be like that. It cannot be like that. Yes, clearly mentioned the intermediate values. But here you don't have intermediate values mentioned. Na? So what will you do is, so at this particular value, what you have to do, you have to select a point, certain point x. You have to select a certain point x. You have to select a certain point x in such a way that